it is. Okay. Well, good thing I caught myself. Otherwise, you would just be watching a silent movie with a form here and with no idea what I'm talking about. Okay, so here we go. So here's a physical form. If you just kind of imagine that I print out the form like this on a piece of paper, a normal person would just kind of fill it in, right? Just write down your last name, first name, circle one of the transportation student will, and then check one of the boxes, and so on and so forth. Gender, check one of the boxes, and pretty normal stuff. Okay. What if I were to tell you, instead of having a form like this on a single sheet of paper, I cut this up so that the last name is a little slip of paper, the first name is a little slip of paper, the middle name, which is just the initial, is its own little slip of paper, gender, its own little piece of paper. In terms of birth date, the month is one little slip of paper, the day of month is another slip of paper, and the year is another slip of paper. So we end up with how many little slips of paper here? Well, let's just call lots, right? Okay, go ahead. Question? No? Okay. So how would you want to fill in a quote-unquote form like that, which is a big pile of little slips of paper? Okay, you probably would not like that, okay? But why don't you want to deal with a form not as a single sheet of paper, but as a little pile of little slips of paper? It still has the same amount of information, right? It still has your last name, your first name, your middle initial, the month of birth, day of birth, year of birth, and so on. But why do you want to fill it in just as one single form, but not as individual slips of paper? Possibly, just with this one, I'm guesstimating around 70, 80 little slips of paper. Sorry? Easier to see this way for someone who's processing it. Anything else? Yep.
Well, the other way would be better because you could rearrange it how you want the information.
Okay, as individual pieces?
Yeah.
But you can also use the wrong piece of information. Just think about the perspective of someone who's processing the form. So they get a pile of little slips of paper, right?
Yeah.
So the chances of picking up something, unintentionally, like first name versus last name, because sometimes certain last names can also be a first name, like Douglas can be first or last name, right?
Yeah.
So if someone is to pick up that little slip of paper and and make a mistake, it would be pretty hard to detect that problem, right? Detect that mistake. Whereas in a form, it is much harder because it's positionally different. Okay, the last name obviously is the first item on that line. Okay. The other question is, what if you run, into another person? Each one of you has a pile of little slip of paper, and they are not stapled, and they go like, and now you have 180 little slips of paper all mixed up. Okay. Then it'll be kind of hard to figure out which one is whose, right? Okay. Whereas if you have two sheets of paper, it's pretty easy. Okay. One is yours and one is mine. I look at my first name, last name, and you look at your first name and last name. Go like, oh, okay, here's yours and here's mine. Done. 80 little slips of paper each, adding to a total of 160. That will take a while to sort it out. Okay. Are there any questions about all of this discussion here? Other than, okay, but why are we talking about this? This is not programming. Well, it is programming, okay? Because up to this point, all we have been dealing with are just plain integers, right? Basically, we're just dealing with integers and characters for the most part. And they're basically the same thing as individual slips of paper. So that means even if I want to represent a date, it will be kind of hard to do it because we still have to represent the month, the day of month, and the year all separately. So for any subroutine that you want to use to process a date, it's going to have a lot of parameters. Okay, so let's go ahead and take a look at a subroutine that someone might want to write in order to. I'll just give myself a task here. Okay, so I'll just give myself a task of writing a subroutine to compare two dates. Okay, and just to find out which one is earlier. Okay, so let's go ahead and see how such a subroutine is going to be written, and how we're going to use it too. So I'll go to the temp folder. I'm not going to save this program. It's not really that important. Okay. So I'm just going to call it compare date.cpp. And I'm not going to worry too much about the types, but I will do at least this much, std.int.h, just so that I can designate the size of the integers within a structure, within a date. Okay. So the subroutine is just int and compare date. And I need to give it two different dates, right? Because if you're comparing, you have to be comparing two different dates. Each one has its own day, month, and year. Okay, so we have a total of 6 parameters. Okay, which is doable. Okay, we can certainly do that. And then with a date, you can use uint 8_t for the types, because with only 8 bits, you are already covering. Well, I guess 16 would be better. Okay, with only 8 bits, you can cover the values from 0 to 255, which are enough for both the day of month and also the month itself. For the year, we need to go up to the thousands, so we'll need at least 16 bits. So I'll just be safe and do 16 bits for everything. Okay, so we have. So we'll go ahead and use the US standard, which is going for the month first. But this time I have to say this is the first month, okay, or the month of the first date. And I'm just going to use this format here. It just makes it a whole lot easier this way. Okay, so month, day, year of the first date. Yep, go ahead.
How did you do that?
YY to copy and then P to paste, lowercase. All right, so now we have all the parameters set up.
Day 2.
Oh, okay. This is not a big problem because the compiler will catch it. Okay, if you try to name 2 parameters of the same identifier of the same name, the compiler will come back and say, "Hey, you cannot do this." Okay, so that's the least of my worry. I'll show you guys some problem that compiler cannot easily check or cannot check at all. But thank you for making that correction. So now I can go ahead and write the code. To write this code, you can do it in a variety of ways. You can do it with a hierarchy of conditional statements. You can do it with a single. You can do it with a single ternary operator. Okay, with other ternary operators inside, and so on. So what I'll do is I'm going to do it the hard way, because you should be able to understand it. Okay, I'm not saying that, you guys, if I give you a homework assignment or a test question like this, I'm not saying that you can. I'm expecting you to be able to do it in 10 minutes. But if I give you the code, you should be able to understand it. All right. So let's go ahead and try this approach. It has one single return statement, which means I have to use one expression. Now that expression can have nested expressions inside, but I should be able to use one single expression to indicate whether the first date is before or after the second date. So to make this even simpler, okay, instead of comparing, I will just say is date before. Okay, so this means it's the first date before the second date. All I need is just a yes, no answer, a true, false answer, as opposed to, oh, it is before, it's the same date, or it is after, which is a little bit more complex. This one is a whole lot easier. Is the first date represented by month 1, day 1, and year 1, is that date before the second date, which is represented by month 2, day 2, and year 2. Is that okay so far? What I'm trying to accomplish here? Yep.
Do you have to put the view in for the
Well, that's for unsigned. Okay, so when I use uint_16, it means it's an unsigned 16-bit integer, which means it can only be used to represent non-negative values, which is okay because day, month, and year, are all non-negative. Well, assuming we don't have to represent any time BC. Yeah. Then it needs to be signed. All right, so we want to use a single return, which means we have a single expression to deal with everything here. So let's see how we can do this with a single return statement. And I know we typically don't do things like this. We don't break up an expression into multiple lines. But since this one is going to be nested, it's a lot easier to look at, if we break it up into multiple lines. So what do you think would be the first question to ask? if we're lucky, we might be able to ask one question and be able to determine whether the first date is before the second date. Compare the year first. Okay, very good. So the first question we want to ask is year 1 before year 2? Because if it is, we're done, right? So here's the question, and this is a ternary operator. The first thing we do is to indicate if year 1 is before year 2, then the answer is yes. Okay, we're all done. Is that okay? If not, then we have to think about something else. So I'm using the second pair of parentheses currently on line 15 and line 17 to contain the else portion of the top level ternary operator. Okay. So if year 1 is not before year 2, we have two possibilities, right? We have two distinct possibilities, and we have to be able to differentiate between those two possibilities. What would be the easy one first? Greater than. Greater than. If year 1 is greater than year 2, then it's definitely not before. Is that okay? So we'll go ahead and go for that one. So we'll say year 1 is greater than, okay, I'll use parentheses here. If year 1 is greater than year 2, then we for sure know the answer is a no. Okay, date 1 cannot be before date 2. Otherwise, we have to take a look at something else. Okay, so at this point on line 18, if execution ever gets to line 18, what does it actually mean? They're equal, okay? So if year 1 equals year 2, what do you want to look at next? Month, right? But basically using the same structure here. Okay, so the rest is really nothing new because we're just using month this time. So we say if month 1 is less than month 2, and because at this point we know year 1 and year 2 are the same already, so the answer is going to be yes, okay? Because we have the same year, and yet the month 1 is earlier than the other one, so the answer is yes. If not, then we have to compare month 1 and month 2 again, this time to see if they are equal, right? Excuse me, I'll take it back. To see if the first one is greater than the second one. If so, the answer is definitely a no. If not, then we have to look at, so at this point on line 22, we have a situation where year 1 and year 2 are exactly the same. We have the same year. And we also have month 1 equal to month 2. We have exactly the same month. Okay, what is left to see? Just day, right? So this time is a lot easier because we just say if day 1 is less than day 2, the answer is yes because we have the same month and the same year at this point. If not, the answer is definitely a no because it's all done. Okay? Now this is definitely not the easiest way to represent this logic. However, given the way I describe it, and given that we have talked about the ternary operator quite a few times already, you should be able to understand how this code works. Okay, now, you might need a few minutes to kind of parse it and understand the syntax, which one is nested within which other one. But once you understand the structure, because I use extra parentheses on this one, just to be sure that we make sure the structure is well represented. Are there any questions about this subroutine? So now we'll go ahead and check a few things, right? Okay, so we'll go ahead and in the main program, we'll go ahead and check a few things. And what we'll do is we'll enter 2 dates, okay, and then we'll do the comparison, and then we'll come up with an answer. That's all we're going to do. Okay. So that means that on line 1, I'm going to have to include stdio. It is just conventional, there's no requirement that you have to put all the pound includes at the beginning of a program, but it is conventional that we put all the pound includes at the very beginning. In other words, since the subroutine is date before, does not require the use of stdio because it doesn't have printf, doesn't have scanf or anything like that, I really do not need to have that pound include up here. I can do it right before main or right before we actually use it. But conventionally speaking, we want to put it up all the way to line 2. And then now we can go back to the main subroutine and actually do something with it. So the first thing that you might notice that is kind of a pain already is to do it like this, okay? So now we have to declare actual variables to store the month, the year, and the day of month. So we have, I can use the same names, okay, well, maybe we should do that. Or we can use, something like, date, 1 day, okay, date 1 month, date 1 year, and then I can just change all the 1s to the 2s, like so here. And then we can go ahead and use scanf to read in the first date and also the second date. So we'll say, scanf. Let's do something fun here, just to relate this particular assignment to something that we have done already. Okay, I'm going to use X here, and this time I'll do a scanf, and we'll try to read in the entire date, which includes both all of the components, day, month, and year, into date 1 day, date 1 month, and date 1 year. Okay, do return 0. I'm not even calling the subroutine that I just wrote because right now we have a problem. Okay, the compiler, if I turn on warn all, is going to chew me up because there's a problem with this code already. In fact, there are at least 2 problems involved here. Okay, so we'll go ahead and compile the program just to see how much the compiler can catch. Okay, because those 2 problems can be big problems down the line. Okay, because even though at this point they don't seem to be a big problem, they can be big issues. So we'll go ahead and just compile the program using warn all. Pedantic is not required because it has nothing to do with the version of C++ that we are using. This is going to be a problem with regardless of which version. And since I'm fairly sure that we have to go back and change the program, I'm not even going to specify -G because we are not really ready to run the program in GDB. And sure enough, we have a whole bunch of stuff happening here. And we want to look at these and see whether they are warnings or errors. And you can see that all of them are warnings. They're not errors, they're all warnings. Which means a .o file is actually created at this point. Okay? As far as the compiler is concerned, it found a whole bunch of problems that may indicate there's an issue with this program. Okay? But syntactically speaking, the program is okay. So it did produce a .o file, which means I could have run the linker and created an executable, but the program is unlikely to work the way it's supposed to. So this means that in your next few classes where you'll be using C++ to write programs, you always want to turn on warn all, and you don't want to ignore the warning messages. So let's go ahead and figure out what it is complaining about. All right, so the first warning is this one here. I'm just going to highlight it. It's a warning. It complains about format %d, which I used in the format string of scanf. Expect arguments of type int star. Now, in the previous class, we understand int star or int asterisk means a pointer to an integer. Okay, pointer to an integer is what is expected. But instead, what did we give the subroutine? Now, this is where new compilers are so friendly that I'm not used to it, because with old compilers, it would just say type mismatch. That's it. That's all it's going to say. Okay, we have a type mismatch, and in this case, old compilers won't even give you a warning because it doesn't understand a format string at all. Okay, but G++ does understand a format string, which is not even a part of the language itself, and it complains about the following. But argument 2 has a type of a pointer to an unsigned 16-bit integer instead. Okay, AKA. Okay, so this is nice as well. AKA short unsigned int star. Okay, so in other words, this is what scanf is expecting. This is what I'm giving it. And they are different. Okay, they're different in two ways. One is signed and the other one is not signed. In other words, %d specifies that I can specify a negative number, and whatever is storing it should be able to store a negative number as well. But what I'm giving scanf is the address of an unsigned number, which is incapable of storing negative values. That's the first problem. Okay. The second problem has to do with the word short. Short means it is not a full length. Okay. A full length integer with this particular platform is 32-bit wide. A short is only 16-bit wide. In other words, scanf is going to overwrite 32 bits or 4 bytes, but I'm giving it the address of something that only has 2 bytes. Okay, so let's think about this a little bit more. Scanf will take that address as if it is a 32-bit integer address, and it will go ahead and overwrite all 4 bytes, starting at the location that we pass to it. Only the first 2 bytes of those 4 locations belong to the variable that I intend to overwrite. What about the other 2 bytes? It's somebody else's. Okay? So that means there's a really high probability that I'll be overwriting something that I'm not supposed to. Not such a good idea. So we want to fix this. There are several ways to fix this problem. Okay, so let's go ahead and go back to the program and see how we can fix it. Well, actually, I'm going to do a little bit better, because what I'll do is I'm going to look at scanf as a man page. Okay, man scanf. There we go. Okay, we'll look up the format string. Okay, so we'll look up the format string, which is somewhere down here. Okay. All right, so we have, this is a good place right there. Okay, D is going to match an optionally signed decimal integer. The next pointer must be an integer pointed to int. Okay, and then we look up here and go like, oh, we got something that might be of use here. Matches an unsigned decimal integer. The next pointer must be pointed to unsigned int, which means it's an unsigned int star. Okay, it's an address of an unsigned integer. That's pretty close to what we want, but not exactly either. Because even though, with %u instead of %d, it will be storing into an unsigned integer, it is still 32-bit wide. Okay, we're still going to overwrite 2 extra bytes compared to what we wanted to overwrite. Okay, and I think scanf has no capability of shortening the width of what it's writing to. So let me just double check on that one. When you're inside a man page, you can type a / to start a search for a particular pattern. So if I'm looking for the word short, I can type / and then short, and here it has something about it. Indicates that the conversion will be one of DIOUXX or N, and the next pointer is a pointer to a short int or unsigned short. So there's a way to modify a %d or u so that it understands it's a short thing. So now the question is, where do I put the modifier? So this is a type modifier character, can appear in a conversion specification. And these are conversion specifications. So I'm looking up the syntax to specify where do I type. Okay, optional type modifier character. So what I'm trying to find out is, where does the H go and where does the U go? Is it XU or UH? Okay, a directive is one of the following: a sequence of white space, okay, that's fine, ordinary character, or conversion specification, which starts with a % symbol. A sequence of characters from the input is converted according to the specification, and the result is with blah, 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 blah. Okay, each conversion specification in format begins with either the character % or the character sequence %n $. Optional assignment followed by the following. So we have asterisk, okay, so the H has to appear before the U because the H is a type modifier character, and then the U is a conversion specifier. And because it's specified in this particular order, that's the way it has to be done. Okay. So this is really useful stuff too. Okay, when you are, well, I guess for you guys, some of you will probably take another 3 years or so, to get out into the field to become an actual programmer. But eventually, this is how you will do your programming. You have to read man pages or manual pages in order to find out, okay, am I supposed to do it this way, or am I supposed to do it the other way? And that's basically one thing you have to do, is to read it carefully so that you can get the specification from the documentation. Okay. Are there any questions about this process here, looking up the man page? Yep.
So how did you figure out that the order?
The order?
Yeah.
Because it specifies, okay, it's kind of implied, it doesn't spell out exactly, okay. So it says, each conversion specification in a format, which is the format string, begins with either the character % or the character sequence % and then some kind of number at the $sign, and then see the following for distinction. Okay, so that's fine. And then it says right here, followed by. Okay, now when it says followed by, it is implied that this is the order where things are expected. They could have written this specification a little bit better, followed by in this order, da 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 da. But it's kind of they could have done it a little bit better. Now the other part that implies that the character or the type modifier has to go first is because it is optional. Because it is an optional part, and then the other one is not optional. It doesn't say optional here. And typically, the optional part has to go before the not optional part or the mandatory part, because the mandatory part is the end of that particular conversion specification. Okay. All right. So now that we have looked this up, I would say today, if you encounter people who have to write a program to deal with this, for the most part, they're not going to look up the man page. Instead, they will go to Stack Overflow and ask the question instead over there and wait half a day to get an answer. Which is really unfortunate, because it's a very useful skill to be able to read the documentation and figure out an answer. Okay, now, to be fair, I think this is an answer, but there's no confirmation this is an answer, right? But since we already know that G++ is really good at checking this sort of thing, let's make it double check. So now I specify HU here because H is an optional modifier, which means it modifies whatever follows it in a particular way. H stands for half. Okay, so instead of a full integer, I want half of the full integer. If a full integer is 32-bit wide, half of that is going to be 16-bit wide. U is designating unsigned, okay, an unsigned base 10 integer instead of D, which is signed base 10 integer. So we'll go ahead and test it, okay? And the actual test is going to be in X, because remember, scanf returns the number of items properly parsed. In this case, what can be the value of scanf be returning? I want all possibilities. Count in all possible possibilities here. So it will go from which value to which value?
0, 0, 2.
-1 to 3, because if I give it an empty file, it will give me a -1. Okay, so you guys are close, pretty good. That's actually pretty good. All right, so let's go ahead and just test this program out a little bit. Pretty sure this time it's going to compile, so I will also specify -G to include debug information. And this time it does complain about unused but set variable, which is something that we have seen before. So I would choose to ignore this one, okay? But I have read the message. Each and every single one, specifies unused variable, and unused variable here, and another one here that is set but not used. Yep.
In the real world of programming, when we are actually making a program for one company, should we ignore that error?
Well, all programs that you are going to turn in, for the most part, you should not have any warnings except for these ones. So if you want to turn these off, specifically, you can say, you can use the -W unused, variable. I think there's a way to turn off specific ones in G++. But there are occasions where it actually makes sense, so it is still okay to kind of take a look at these. So So G++-O, I'm linking it now using cmpdate.o, which is the object file. Whoops, forgot. Specify the name of the executable first. There we go. All right, so now we can test it. And I'm gonna just test it, using the usual way. I should have set it up a little bit differently. Put a breakpoint on line 38, run the program, give it a date. So the first thing is to give it an actual valid date. Let's say today. Like so. And now I can check all the things that we are supposed to check. First of all, X is 3. Okay, so that means scanf properly parsed 3 things that we asked it to process. How many things did we ask it to process to begin with? 3 things, right? Okay, they're separated by a slash. So we are supposed to have date 1 day, date 1 month, and date 1 year properly stored at this point. So we'll go ahead and take a look at that. Print date 1 day, that's good. Month, that's good. And year, that's good as well. Okay, so at this point I have fairly good confirmation that the scanf line is working, so now I can proceed with the rest of this program. Okay, so I would write programs this way. Okay, I would do confirmation along each step and do not make assumptions. Okay, moving on and think, well, I'm assuming scanf is going to work properly. Okay, what if it doesn't? Okay, all right, so let's go. Yep, go ahead.
Put the you switch the day and the month. You put 16 into the month.
Oh, you're right. So the scanf line got it wrong. I think it has to do with the scanf line. Okay, very good. Good observation there.
Well, yeah, because you wrote it to take it as day, month, year instead of
Month, day, year. Okay, very good. Well, you know what? That brings up a very good point. If I use this particular format, it is very easy to switch parameters and not notice that I have accidentally switched it. Because date 1 day is an integer or unsigned short integer. Date 1 month is also an unsigned short integer. If I exchange those two, hey, GCC cannot possibly catch it. Okay, let's go fix it first. Good catch. Here we go. And now we can scan for the second date. Okay, I just copied, paste, and modify. And remember what I said earlier this year? Every time you copy, paste, and modify, you kind of have to ask yourself, is there a better way to do it? Okay, and the answer is yes, there are much better ways to do this. And we'll kind of talk about that once we get to structures. Okay. All right, so now that we have 2 dates read, we can now compare them, right? And that's going to be one call that is going to take a little bit of time. So what I'll do is I'm going to use a printf to give us the result. But this is going to be one pretty long, argument. So I'll use this format again, where I break up the arguments and I'll have multiple lines, just to specify the arguments to printf. Printf has a format just like the other ones. Let's see. I'm just thinking about how to print it out here. And I want to use only concepts that we have talked about so far. I don't want to use anything that is different from or new to what we have talked about so far. So I'll go ahead and do it this way. Okay? I'll tell you what I want to do, and then I'll go ahead and do it. I want the output of this program in the form of a printf to say this date is before the other date if I can confirm that. I wanted to say this date is not before the other one, or not before if it's not the case. But I do want to use the same month, day, and year in the printout, and not just say the first date is before or not the second date. I actually want to spell out, okay, March 21st, 2015. So how would I go about doing it? Using only constructs that we have talked about so far. There's one thing that you can do in printf using a %s, so you can pass a string as a parameter, but I'm not going to use it because it's new to us. I want to use only things that we have talked about so far. I can make the format string itself the result of a ternary operator. Okay, so let's go ahead and think about how we're doing this. Okay, so as I said, I want to turn this into a ternary operator. Now, if it's a ternary operator, I can pre-fill the structure like this because it starts with a condition and a true value and then also a false value. We know all ternary operators have these three components. Even if I don't know what to specify as the condition, I know if it is true, we want to say this, okay? %XU, %XU, %XU is before %XU, 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 \n for the end of line, okay? So I am specifying a format string that requires 6 individual components. 3 for the first date, 3 for the second date. The only part that is really useful here is before. Are we doing okay so far with this format string? The other format string is going to be about the same, so I'm going to do a copy and paste. And once again, every time you copy and paste, you kind of have to ask yourself, is there a better way to do it? So I'm going to do this one to, here we go. It's close to copy and paste in the entire string. It's just a little bit short. And okay. I'm just going to say is not before. All right, so given that, what am I going to specify as my condition?
The return value of your function.
Yep, exactly. Just use the return value, right, of the function that I used before, and it's called isDateBefore. So we'll go ahead and call that function isDateBefore, and this is going to be a long list of parameters, right? Because I have to give it date 1. Okay, do I specify year first? See, that's the other problem, okay? I have to remember the ordering of month, day, and year when I'm passing the parameters. This is equivalent to passing little slips of paper instead of a form. Okay, because with little slips of paper, okay, which one is supposed to be the first, the month or the day or the year? Well, it depends on the country, right? In the United States, we go month, day, year, but in Europe, how do they do it? They go year, month, day. I think in Great Britain, it's the other way. It's day, month, year. Do you guys know that GB does not consider itself a part of the EU?
They still use the pounds, right?
Sorry?
They still use pounds, right?
They still use pounds and they still drive on their right side of the road. That would be a proper way to put it. Because they think their way of doing things is actually the right way of doing things. Which makes driving a stick shift kind of interesting because instead of shifting with your right hand, you'll be shifting with your left hand. So for people who have been driving years in the United States, with a stick shift, that's going to be a difficult adjustment because not only do you have to focus on driving on the other side of the road, you'll be shifting with the wrong hand too. All right, so let's go ahead. This is month, day, year. So we'll, whoops, go back to code here. All right, month. One thing you might have noticed already, I'm hoping that you have already noticed it, is the amount of typing I have to do. Lots of typing, right? And then we have to do type dates too. If I were to mistype one of these, like right now, do you think the compiler would catch it and go like, hey, this doesn't make any sense. I mean, we're dealing with date 2 as the second half of this function, not date 1. Do you think the compiler would catch it? Nope. None whatsoever. Okay, the compiler would just go like, well, it's an unsigned short integer, and it's good. Okay, so this is the problem of not using structures. Okay, this is a program that's going to work. Okay, I can fix it so that it works. That's not the point. The point is, in the process of writing this really simple program, I could have made a number of mistakes. Some can be caught. Okay, like the scanf one can be caught by the compiler, but a whole lot cannot be caught by the compiler. Okay, just this one, okay, for those of you who did not catch it, I mistyped the date 2 with date 1 here, okay? But the compiler would not be able to catch this one. All right, so that's fine. Okay, let's go ahead and see if it works. Okay. So, and we have 508. Expected matching int argument. All right, so it's printf's turn to complain about not having
the
integer.
corresponding addresses for what should go in those.
Oh,
formats.
thank you. Because I did not specify anything, right? I just specified the format string, but I did not say, what goes into the arguments. Did everybody understand what I missed? No? Okay. I specified the format string, right? The format string spells out I have an unsigned, short unsigned integer, a short unsigned integer, 6 of them, okay? Exactly where are those integers? Nothing. I didn't specify anything. But Tech, I distinctly remember you complain a whole lot about typing date 1 ... Well, what did those go to? They were arguments to whom?
The is date before function.
Is date before function, not to printf. So as far as printf is concerned, it has a format string that specifies 6 empty slots or 6 placeholders, but I did not specify what to go into those 6 placeholders. Are we doing okay so far with this mistake? That was actually completely unintentional. It's definitely my fluke. That it's just I goofed up here. Okay, but did you guys understand how I goofed up?
I saw it.
You saw it? Okay. Well, I left it up to the compiler to complain about going, oh, there's so many messages here. But did you guys see? Okay, all right. Everything from line 41 to line 44 specifies the format string to printf. In other words, it tells printf, this is what I want you to print. Okay? There are 2 versions. One version says is before, and the other one says is not before. But in each version, it requires 6 unsigned short integers, which is completely missing from the arguments to printf. But some of you, which probably including myself, is saying, well, but I just specified a whole bunch of stuff, with date 1 day, date 1 month, date 1 year, date 2 blah, blah, blah. They didn't go to printf. All of those went to where? Went to is date before as a subroutine. So now I have to repeat the same process and just use all the same 6 parameters here. Okay? And I'm going to do it in a way when you'll be asking, is there a better way to do it? Because I'm just going to copy and paste. So it is your job to ask that question. All right, so there's an easy way to do that. It's y, close square bracket, close parentheses, go to the point where you want to insert it and do a p. I just found out what I did on the keyboard. All lowercase, by the way. Nobody's interested, I can see. It's some magic thing you did in VI. Okay, fine, let's move on. Okay, but if you did not know that trick, then you have to do a whole lot of copy and pasting. Most of you, some of you at least, are thinking, I could easily do that with a GUI editor. Just select with my mouse, right click, or just Control C and then Control V on the other side. What is the big deal of using VI? What if you're using a dumb terminal? Then there's no copy and pasting. I would never use your dumb terminal, ever. There we go. We need an extra comma here because we need a comma to separate the format string from the rest of the arguments. All right, there we go. I think this may be it. We'll see. All right, we got one expected primary expression before the parenthesis on line 44. Right, so let's go to line 44, and I will go to match the. Oh, there we go. That one should not be there. Okay. Let's do it again. All right, so this is all good because it's just complaining X is set but not used. You know, that's the one that I use to count the number of things I have read using scanf, which is not really useful. Okay, so we'll go ahead and just say G++ -O, CMP date, O. All right, so the moment of truth. Let's run this program. It doesn't give me any prompt because I did not ask it. Okay, so I have to enter 2 different dates. So let's enter Pi Day, which is March 14th. So did you guys do anything fun on Pi Day?
I made a pie that had the pie symbol on it.
Did you do it on Pi time, at Pi time? Like
I
3:14?
ate it at pie time.
You ate it at Pi time?
Yes.
But there are 2 Pi times. Did you do it the 24-hour format, or did you do it twice?
I did it twice.
You did it twice. Very good. Okay, so we have Pi date, and then Pi, well, you know, not so Pi date, which is today. And it comes to the right conclusion, which is great. So the program does work. Can we just leave it like this and be done with it, you know, like not talk about structures? But the whole point is to talk about structures, right? So we'll go ahead and talk about structures. All right. So what we'll do is I'm going to write another program that makes use of structure. So we have CMP date 2, okay, version 2. It's always better than version 1. And with this one, we'll go ahead and include the same stuff, which is standard in.h as stdio.h. In other words, I'm not going to cheat using cin and cout instead of printf and scanf. So we'll use the same low-level basic mechanisms to do all that stuff. But instead of using individual parts, this is new. Okay, this is new. I'm going to say struct, give it a name. Okay, I'll call this date or date structure. And this is how we define a structure in C++, which consists of the keyword struct, an optional name date, okay, because we have to refer to this structure from time to time, so it's helpful to give it a name. There are occasions where you do not need to ever refer to the structure itself again, then you don't need an actual name for the structure, okay? And I'll talk about what the structure is as opposed to a variable of a structure type, okay? Those 2 things are completely separate, but it's very easy to distinguish between those 2. Inside the date structure, now I can start to say what's inside it, okay? We have year, month, and date. Now this time, the ordering is not important anymore. So I can say int 16_t year, unsigned integer 16 month, and unsigned integer 16 day. And I can exchange these things all day round, all year, all day long, and it doesn't really make any change, okay? The ordering is not important at all in here. All right, let's go ahead and do something with date as a structure, okay? So the first thing I'm going to do is I would go ahead and read it, okay? So I will say int read a date, and this time I'm relating this back to pointers because now we have a pointer to a structure. Let's see. Is this what I want to do? Let's not do this one first. Sorry. I'm just going to re-implement the function to find out whether it's the first date earlier or before the second one. So I'm going to do this one first. Okay, so date D1, struct date D2. There we go. All right. So the first thing you might notice, as a difference between this version and the first version is date before only has 2 parameters now instead of 6. And instead of using 3 individual parameters for one single date, each date is now represented by one single argument. So D1 is one argument, and so is D2. D2 is another argument. But when you look at D1 and D2, they're not unsigned integers. They're not unsigned 16-bit or 32-bit integers. They are now of the type of struct date. Okay, it has a type of a date, D-A-T-E with uppercase D. So that means D1 has its own components called month, year, and day, and then D2 also has its own components called month, year, and day. Okay?
So they're just like two mirrors of the same step.
Say again?
They're like two different.
Right. They're basically two different dates, but they have the same internal structure, even though the structure may have different values. Okay, the individual items can have different values. Okay, so I'll go ahead and just finish this one first, and then we'll talk about how what is the actual type and what is the variable or parameter of that type. And then with this one, I'm going to use the more conventional way of doing things. I'm going to use a conditional statement. So I'll say if D1.year is before D2.year, else, okay, I always do it like this, especially in this case, I know we have to specify something in else. So this one can return a 1 right away, and then this one needs to ask some additional question. So it will say if D1.year is greater than D2.year, we'll do something, otherwise we do something else. If the year of the first date is after the year of the second date, we can just return to 0 because there's no way the first date is before the second one. Now we have the year being the same between the two dates, so we will go for the month instead. Basically the same structure as before. If it is before, we can just return a 1 and confirm the first date is before the second one. Otherwise, we will see if it is greater than. If it is greater than, we turn a 0 because the year is the same, but the month is later. Otherwise, we have the month and the year being the same, so now the day itself will determine the actual result. So if D1.day is less than D2.day, and I'm going to pass the row sheet before I forget. Keep forgetting it. It's the last column. Okay, so if D1.day is before D2.day, once that we have confirmed the year and the months are the same, then we can just say return 1 here and return a 0 here. There we go. Exactly the same kind of logic, except this one uses a conditional statement instead of a nested ternary operator. Yep.
The period after D1 specify that you're just looking at that specific value?
That is correct. The dot, is the same thing as apostrophe S in English. So D1 dot year is basically saying D1's year. Okay, it's kind of like the possessive stuff that we do with natural languages. Okay. All right. Let's go back and look at this program just the way it is right now, and this time we'll talk about something that relates to eating. We'll talk about a cookie and a cookie cutter. Okay. How do you use a cookie? You eat it, right? You make it, you eat it, and it's filling, supposed to be. What do you do with a cookie cutter? Do you eat a cookie cutter? When was the last time you tried that? Was it delicious? Was it good? Okay, so I can see we have a few benders in this class. Bender from Futurama. Yep, the robot. So we don't eat cookie cutters, right? We use a cookie cutter to cut out cookies. When you use the same cookie cutter to cut out, let's say, 20 cookies, what can you tell me about those 20 cookies? Not even knowing the ingredients that go into the 20 cookies, what can you tell me about those 20 cookies coming out of the same cookie cutter? The same shape. Okay, very good. Okay, they have the same shape. In other words, if you use St. Patrick's Day is coming up, so if you use a hat-shaped, cookie cutter, all the cookies coming out will have the shape of a hat, right? Now, some may have chocolate chip, some may have, raisin, and some may be, oatmeal based, and the other one will be more traditional, but they will all have the same shape. Is that making any sense? Okay. So looking at this program right now, as it is just right now on the projector, which one do you think is a cookie cutter? Can you name the cookie cutter in this case? Because you only got one. Hmm? The structure definition is defining a cookie cutter. Okay, very good. So from line 4 to line 9 is the definition of a cookie cutter. And we even give it a name. Okay, the name of this cookie cutter is date. So that later on, for the rest of this program, we can say, oh, go to the drawer, find the cookie cutter name date, and stamp out 2 cookies for me, 4 cookies for me, or whatever number. Is that making any sense? And if you use this cookie cutter to cut out a cookie, every single cookie will look the same. In other words, every single one will have a month, it will have a year, and it will also have a day as what we call members. Okay? So when you look at the subcomponent of a structure, each one is called a member. So each one is a member. We have a member called month, a member called year, and a member called day in this case. Can you see any cookies in this case? In other words, did I use the cookie cutter to stamp out anything? Or is there any line here that might suggest that I'm using a cookie cutter and stamp out something? Can you identify the line number of that? Well, you just have to find out on which line I refer to the name of the cookie cutter, which is uppercase D, date.
11.
Line 11, exactly. So on line 11, I use the cookie cutter, okay? This is basically saying cookie cutter. This is the name of the cookie cutter, and this is the cookie that I'm cutting out. So D1 is not a cookie cutter. D1 refers to a cookie cut out using the cookie cutter struct date. Okay? And D2 is another cookie stamped out from the same cookie cutter. So here's the next question. But doesn't that mean that D1 and D2 are really the same thing? Well, they have the same shape, but one can have raisin and the other one can have chocolate chip. And I obviously will have both of them. I don't have any preferences in that case. They're all good. Okay? Are there any questions about the shape versus the content? Okay, they can have the same shape, but the content can be different. Okay. So what about this part here? It is referring to a particular part of a cookie. Okay. Here's another question. If I give you a program that has 500 struct definitions, okay, it's 500 things that look like from line 4 to line 9, okay, 500 of those. Does it automatically make this program use up a lot of cookie dough? You walk into a kitchen, okay? You walk into the kitchen, you open up, one of the cabinets, and you see, wow, I have never ever seen this many cookie cutters. Does that imply that whoever owns the cookie cutters also own a lot of cookie dough? Nope. Well, there's that potential, but the implication is not always, right? In other words, someone can be a cookie cutter collector, but does not own an ounce of cookie dough. Is that making any sense? Yep.
You're saying it has a lot of structure, but nothing within it?
No. I'm talking about structures, cookie cutters that can be big or small, but since it is only a cookie cutter, it does not imply that you are using up any cookie dough. Just because you own 500 cookie cutters does not mean that you have to stock up any cookie dough. Okay. On the other hand, I can go to another kitchen where there's one single cookie cutter in a drawer. Okay. But that person can have 500 pounds of cookie dough in the fridge. Well, that has to be a pretty big fridge then, right? Because I can use the same cookie cutter and stamp out 20,000 cookies. Are you guys seeing the difference between what is a cookie cutter and what is an actual cookie? Okay. What do you think RAM is equivalent to? RAM, which is the memory of your computer, is RAM cookie cutters, or does cookie cutter take up RAM, or do you think cookies take up RAM? It's the cookies. Okay. Okay, so it's what you stamp out using a struct that is consuming memory. It is not the cookie cutters. So this means when the subroutine is called, D1 and D2 would actually use up memory of your computer. But before, this thing is just sitting here. It's not going to use up any memory at all. Okay, are there any questions about that? The equivalence of cookie dough to memory resources of a program. And I can already see, many people will walk out of this class today thinking only about cookies and not have any memory whatsoever about structures and all that stuff. It's like, oh, whatever, And they'll all be going to the vendor machine or
The bakery.
No. You don't go to the bakery. You can go to Subway and ask the person to microwave the cookie for you, so you have soft and chewy cookie. I saw that once ago. Like, what? You can do that? Yeah, we can do it. Yep. All right. So this is one. Okay. Let's go ahead and take a look at another one. Okay. Let's take a look at this one. Let's use the word scan because we like scan. Okay. Instead of read, it's scan. So this time we scan a date instead. Okay. So the way we scan the date is to give it a structure. Okay. And we name a cookie cutter, and this time we will cut out a cookie. So we just call it D because there's only one of them, and then we can read into it. Okay, so we'll say scanf. In fact, we'll just return scanf and use the same format string as before, which is %u/%u/%u. Close the thing here, and then we'll say d dot month, d dot today, and d dot year. Here we go. All right. So scan date is basically just a subroutine to read a particular date from standard input file. Okay, because scanf just automatically goes to the standard input file. And it's the same as the previous program. Okay, we read the month first, and then the day, and then the year, except this time we turn it into a subroutine, so I can use D1 or D2 to pass to this subroutine, so we don't have to copy and paste the code as much this time. Is that making any sense so far? Okay. And then we can, well, actually, it should not make sense, at all at this point, but I'll just say that it's okay. Okay, we'll find out what the problem is. So we have another one, which is print date. Okay, same kind of stuff, except this time we'll printf instead. Okay, so printf does return the value, but for the most part we ignore that return value. So that's okay. That's not a big deal. So %u/%u/%u, d dot month, d dot day, d dot year. All right. So now we can move on to the main program. The main program needs two cookies. One is D1 and one is D2. And we'll pretty much keep the same structure as last time, except this time, instead of two separate scanf, I can now use a subroutine. Okay? If I were to keep it exactly the same, I'm going to have int x here, and x equals to scan date. I'll give it D1. And then we have x equals to scan date D2, and I'll just leave the program like this at this point and try to compile it, okay? Because one thing that you don't want to do is to write too many lines of code and then compile the program only to find out, oh man, we got a lot of problems here. I can already tell you that we have problems already, as it is right now. On line 53, for sure, we're going to have problems, because scanf does not want the value of something, it wants the address of something. Okay, and what I'm giving it is the content. I'm not giving it the address. So, but we will let the compiler complain about it and see what kind of message is coming out of the compiler. So we turn on warn all, just compile the program, and it complains, it chokes on it, and And this time it is still a warning because it is just saying that it is not agreeing. It is not agreeing to what is what it's expecting. So in this case, it complains on line 53. The format HU expects an argument of short integer and a short unsigned integer asterisk, which means it's an address or pointer to a short unsigned integer. But argument 2 has the type of just int. Okay. So we have a problem here. And how are we going to fix that problem? Okay, so let's go back to the program and I'll go to line 53. And what the problem has to do with d.month and d.day and d.year are not addresses, they're values. So how do we fix this problem? Ampersand. Okay, but hold on a second here, Tack. We have never ever talked about ampersand on a member of a structure, right? We talked about the concept of ampersand individually, separately, to take the address of an integer. And then today we talked about the structure and members of a structure. Can you tell me what is d.month? It's an unsigned 16-bit integer, right? So whatever we could apply to an unsigned 16-bit integer before can apply here as well. In other words, if you put extra parentheses, which is not really needed here, if you look at this whole thing, d.month as a whole thing, it is just an unsigned integer, and it's stored somewhere, right? If it is stored somewhere, it has an address, so I can take the address of that thing, just like before. Is that making any sense so far? Okay. And you will see stuff like that, especially in the exams, where I would throw in combination of things that individually you have seen it before, but combined it might be the first time you see it. But then what you have to do is to understand what each thing is doing. Ampersand is just saying I'm taking the address of whatever is following. It can take the address of an integer, it can take the address of a character, it can take the address of a member of a structure, it can even take the address of the entire structure. Because all it is doing is just to say, I don't care about the content of that thing, I only want to know the address of that thing. So you will have to be able to apply these things so that when you see a combination that is new to you, you just have to apply each thing individually as you have learned it. Okay? As I said, the parentheses are actually not needed because the grouping of the dot has a higher priority compared to the address of. So we don't need to do that. Okay, so let's see what this one is going to do. So we'll say history and 521, repeat that command. Now it's just complaining about variable x, which is good. We fixed that problem. Okay, cool. So let's go ahead and run this program, right? And we have D1 and D2 here and 968, so we are ready to link the program. So CMP day2 is the new executable. This is the object file, and then we'll just go ahead and GDB the program. Compare day2. Oh, forgot the -G before. Right here. If you don't supply the -G, then GDB will not be able to locate the source code. So that's why you have to kind of go back and recompile and then relink it. And this time I can look at the source code, put a breakpoint on line 66, put a breakpoint on line 68, run the program. We're at breakpoint 1, which is good. If I continue execution, it will ask me for the first date. So let's do a pi date. And the second date is today, so just like before. And now we are on line 68. So when I look at each individual structure, D1 and D2, I should see the 2 dates already. No, that's not what I entered. That certainly is not what I entered either. What is happening here? What do you think? Well, let's go back to the program first, okay? So now that we know the program is not working, let's go back to the source code and see if we can figure out what is wrong with this program. And the problem has to be within this portion, okay, because we are not even comparing just yet. So what do you think is the problem?
You get to the address.
Okay. On which line? You mean on line 51? Okay, let's think about what is happening when we, yep, go ahead.
Oh, is it because scan date is returning the number of elements that are scanned into scanf?
Yes, it's returning the number of things that it correctly parsed. And since I entered the dates in the correct format, it would have returned 3. If I checked X, it would have been 3 anyway. So that's not a problem. It's not because I entered the dates incorrectly. It has to do with something else.
So you print the value of the addresses, not the value of the address.
You're getting close. You're getting very close. Because remember last time we talked about the swap subroutine? What was the problem with the first version of the swap subroutine that I wrote? It performed the swapping just fine, but then what happened to the parameters?
It didn't set back the
Exactly.
values.
In other words, when you look at scan date, this is not the address of a date. This is a date, okay? And if you remember, I'm hoping some of you still remember, what is, when does D start to exist and when does it die? It's a parameter, and the parameter has the same lifespan as a local variable. So what is the lifespan of a local variable? Yep, it does not even exist until the subroutine is called, and then when does it die? When the subroutine ends. Okay, so that means we don't even have a D until on line 66 we actually call scan date, then D starts to exist. Okay? But it's a parameter. I mean, surely a parameter is different from a local variable. It is. How are they different? They have the same lifespan, but there's something different about them. You know, being a variable versus a local variable as opposed to a parameter. What is the difference between those two?
Parameter sets a rule as to what you can send to it.
How they start the initial value, right? A parameter has its initial value specified by the invocation. Whoever is calling it is responsible to say, hey, you start with these values, as opposed to a local variable where it is just gibberish, okay? They just start with gibberish, and the subroutine itself is responsible to initialize local variables. In this case, D1 on line 66 is the argument, which means I use the existing value of D1, which is completely uninitialized at this point, to start off the value of D. In other words, it's just going to copy month, day, and year of D1 to parameter D. And then after that, there's no linkage between D and D1 anymore. So the argument, or the parameter D of this subroutine, is now completely independent. It just starts with the same value as D1. Okay? And then I do the scanf. The scanf is not a problem. We fixed that problem already. So by the time we get to line 54, which is the end of this subroutine, what is going to happen to D as a parameter? It goes away. It goes to the recycle bin. What happened to the values that we have just read? It goes into the trash can too. And what is going to happen to D1? Absolutely nothing, right? D1 stays the same as before. Gibberish, all gibberish. Okay, so that explains why this program is not working so far. How are we going to fix it?
Pass my address and value.
Pass the address. Yep, go ahead.
I was gonna say get rid of the return before scanf and then return the structure.
That's an interesting idea. You can return the structure, but there's a different way to do it that relates to pointers. So what we can do instead is to say, hey, maybe we don't want scan date to use this. Maybe we wanted to do this instead. Now that one little asterisk symbol, the little star symbol, is very significant in this case because we are now changing it so that we are saying, oh, scan date is not expecting a date, okay? It's not expecting the address of a date. Is that okay so far? Okay, when you specify the type of a parameter or a local variable, this is one whole thing. Okay, in fact, you can put parentheses around this block of text here and would not change the meaning whatsoever compared to what it is now. So now D is no longer a date, it is a address of a date. Are we doing okay so far with this? Okay. So let's go ahead and change it. But then we'll have some other problems later. Okay, so I'm just going to do one change at a time, and I just put parentheses here to emphasize the asterisk applies to the left-hand side and not really to the right-hand side. Because together, struct date star means the address of a date structure. It kind of reads backwards, okay, so it's kind of awkward that way. Okay, so the way it is right now, it's not going to compile. The compiler is going to have a pretty hard time with this because this time it is an actual error because it has to do with how we call scan date as opposed to how it is defined. The error is on when we call the scan date cannot be used because D1 is not the address of a date, it is an actual date itself. Okay, so that means we go here and we change it. All right. Scan date is expecting the address of D1 of a date. So how do we fix this? I just misspoke and gave you the answer. It's the address of, right? So you know the ampersand is going to fix this problem. Okay, very good. Sounds like we got it all, right? Let's go ahead and recompile. And the compiler says, no, not quite. Okay. Scan date cannot be used as a function. It's because it would not even compile. The first error is on line 51. It complains that D was not declared in this scope. Oh, I think I put in the parentheses incorrectly. In the type definition, I cannot put in a parentheses like that. It has to be like that. Sorry. Okay, so let's go through this again. It's still going to complain about it because this time the complaint is on line 53, and the error is request for member month in D, which is of pointer type, and maybe you meant to use the arrow, okay, which is correct, but I'm not going to fix it this way. Okay. Okay. Let me show you what I mean by that. Okay. So we go back to here. So what the compiler is complaining about is I should have used this. I'm not going to introduce anything new today. So we're going to take this back and say, all right, we have a problem. The problem has to do with D is no longer a cookie. Okay? It used to be a cookie. Now it's not a cookie. Now it's just an instruction to get to a piece of cookie. Okay? Second cookie jar, third cookie from the top. Okay? That's where the cookie is. It's the instruction. So I can no longer refer to a component of a pointer to a cookie. I have to go get the cookie first. Then I can say, hey, with this cookie, I want to refer to only this part. Is that making any sense? No? You want to eat a cookie. And I give you a little slip of paper. Instead of a cookie, I give you a little slip of paper that spells out where to find that cookie. It's in the kitchen, okay? On the second shelf, in the pantry on the left-hand side, cookie jar number 4, because I obviously have a lot of cookies, and you are only going to eat the second cookie from the top of the cookie jar, okay? And I wrote everything on that slip of paper, and you get a little slip of paper. Are you going to eat that slip of paper? So that means the address, the instruction to find a cookie cannot be used the same thing as a cookie itself. Is that making any sense? So what do you do with that slip of paper if your objective is to eat a cookie? You follow the instruction, you get to the cookie, right? The asterisk means this is instruction to find a cookie. This wants to use a particular component of a cookie, but not how to find a cookie. So how do I combine those two things together? Don't you think the first step is to find a cookie first? Follow the instruction, find a cookie. Once we have the cookie, then we can say, oh, I don't want to eat up the entire cookie. I just want to eat up this part of a cookie. Is that making any sense? Okay. Just thinking about it. We have this thing here, okay, which is also called the reference. We follow the instruction to get to something, right? We talked about that last Wednesday. And then we have this thing here, which is, apostrophe S, okay? Something has multiple components, I just want one of the components. How do we combine these two? Which one needs to go first? In this case, on line 53, which one has to go first? We have to go find it first, right? So we have to apply this first, okay? So we'll say, okay, what is it applied to? What is an address in this case, in this subroutine? There's only one thing that can be an address. Which one is it? Parameter D, okay? So we say D is the instruction to find a cookie. Let's follow the instruction. And what is that? If you look at the result of following the instruction to find a cookie, what do you get? A cookie. Woohoo! But unfortunately, I did not ask you to eat the whole thing. You can only eat a part of it. Which part of it? Month. Okay? So you applied the dot month to that whole thing. Is that okay? Now this will take a little bit of time to absorb, but this is how it is going to work. So we say, follow the instruction to get to a cookie. And you know what? That will only give me a cookie, a part of a cookie, which is an integer. Then I need to take the address of that again, right? Because this is in a scanf. A scanf says, I don't want a chunk of a cookie. I want to find out where to find that chunk of cookie. So you have to apply the address of over the entire thing and say, now I want the address of that thing. Okay, let me just finish this and then I'll go ahead and possibly spell it out in a slightly different way. Okay, we will look at this in a slightly different way and hopefully that will be helpful. All right, and it's a long line, but that's just the nature of it. All right, so the way we look at this, the other way to look at this is we start with D, which is a pointer. Okay, it's the instruction to find a cookie. So the first thing we do to it, okay, this is actually the wrong place to start it. Okay, we start D down here. So we look at D, it's a pointer. Okay, it's a little slip of paper with the instruction to find a cookie, which you cannot eat, right? You cannot eat the paper, you can eat a cookie. So what we want to do is to say, I'm not interested in a piece of paper, I want a cookie. Okay, that finds you a cookie. But then after this, you say, I don't want the entire cookie, I want a piece of the cookie. Because in this case, I'm only interested in the month of a date, not the entire date. Okay? So that means we have a dot operation here, where one side is specifying the entire cookie, the other part specifies month, which is the name of the component that we want to use. Is that okay? So when you look at the dot operator, it gives you a part of a cookie. But as far as scanf is concerned, it doesn't want a piece of a cookie. It wants to know where to find a piece of cookie. Because you're asking scanf to, I don't know, dye a portion of a cookie with a color, green, St. Patrick's Day is coming up, okay? So that's why we want to take this whole thing and say, oh, we don't want a piece of a cookie. We want to find out where is the address of that chunk of cookie is. So that's how everything is specified here. The ampersand is applied last to the whole thing, and then the second last one is to specify which component, and then the first operation is to follow the instruction to find the cookie itself. I know we are running out of time, so I will spell it out one more time, but this time using the projector, okay? So hopefully you guys can kind of follow this. This is the instruction to find the cookie. This is the actual cookie, the whole cookie. I don't want a whole cookie, I just want a portion of it. So this is now becoming a portion of the cookie that I want to change. In other words, I don't want chocolate chip, I want raisin, right? So I want to specify which chunk of the cookie I need to patch. Yep, go ahead.
Yeah, you just asked it.
Okay. But scanf cannot do that, right? You cannot just say, oh, here's a chunk of a cookie, I want to change it to something else. You have to give it the location. Where is that chunk of a cookie? So now we have the location of a particular chunk of a cookie where you originally start with the instruction of finding that cookie to begin with. So the only thing that we are adding today is really this part. Because last week we already talked about pointers and dereferencing. But do you guys see how things are connecting? You know, how they can combine to make quote unquote new things, but in terms of concept, they're not actual new things. It's just a way to combine operators so that we can do things that we need to do. Okay. Okay, hopefully this will work. So we'll go ahead and compile the program and then link it. Yep, it compiled just fine. We'll go ahead and link the program. GDB, set up a breakpoint on line 47, run the program, specify two dates, print D1. Oh, did it call it D1?
You're in the original program, the first one you wrote.
Oh, thank you. Forgot the 2. 68. Run the program. D1, D2. So you can see, you know, GDB is really quite friendly. You know, it tells you not only that D1 is a date, it also breaks it down into its individual components and tell you what it is. So that's the end of today's lecture. I know we ended the lecture late, so I'll give you guys 10 minutes to, you know, go get something to eat, drink, whatever. You know, we'll restart the lab portion in about 10 minutes.